So the nth root of a, left-hand side, is the radical notation. A raised 1 over n is the rational exponent notation. So suppose we have, let's just say, example, oops. We have negative 32 raised 1 over 5. I look at 1 over 5, and that immediately tells me that I'm dealing with the fifth root. And whatever I see inside the parentheses will simply go inside the radical. Which is why earlier I mentioned that anytime we have an exponent, it is always best to put the expression in the base within parentheses. This way, you will not make mistakes. The previous problem was quite straightforward because we had 1 over 5 that immediately tells us that we are dealing with the fifth root. But in this case, I don't have simply 1 over 4. I rather have 3 over 4. So we have to use properties of exponents. So negative 16 raised q, or raised 3, raised to the power of 1 over 4. One of the properties of exponents tells us that if we multiply those two, we would end up getting 3 over 4. So I can rewrite negative 16 raised 3 over 4 like I did on the right-hand side. So now I have a fourth root. And whatever that is inside the fourth root, I put it inside the radical. Keep in mind, this particular problem, we're not going to simplify further. Previous problem, for instance, we did this at the very beginning. The fifth root of negative 32, I could write it as fifth root of negative 1 times the fifth root of 32. So negative, because it's an odd root, 32, I could write it as 2 raised 5. The root and the power will get cancelled. So I get negative 2. That is the simplified version. We cannot do that in this particular case because we have an even root and we have a negative number inside the root. So we will just leave the answer as is. Now, one may ask, well, how do we deal with this in mathematics? Well, there are ways to deal with this. We will introduce that concept gently in chapter 8 or later in chapter 7. So here I have 7x plus 1 raised 5/3. And 5/3 is not a standard root. So we're going to use the properties of exponents. And write it as 7x plus 1 raised 5 and raise the entire expression to 1/3. The rationale is that if I multiply 5 and 1/3, I'm going to get the 5/3 there. Now I know that 1/3 simply means the third root. And I can simply write 7x plus 1 raised 5 inside that third root. So we are going to rewrite x squared plus 4 raised 11/3 as x squared plus 4 raised 11 and raise the entire expression to 1/3. We know 1/3 will correspond to an odd root. So, excuse me, at the third root, which in fact is the odd root. So 3, third root of x squared plus 4 raised 11. So if you can figure out the middle expression or how to rewrite in terms of the middle expression, going from there to the radical notation is quite straightforward. So we know from the properties of exponents that if the bases are identical, which in this case they are the same, we can put the common base. And since we see a product here, we add the powers. When I add 4/3 and negative 1/3, I get 4 minus 1 divided by 3. Since 3 is the common denominator, so the numerator would be 3/3, which would be 1. So y raised 1 is simply y. Once again, we are multiplying two rational exponents or expressions in rational exponent notation. So the bases are identical and we are multiplying. So put the common base and add the powers. So x raised 7/4 plus 11/4. We have a common denominator of 4, so we combine the numerators. So x raised 18/4. That would give us x raised 9/2. Certainly, I can simplify this further. You may not be able to see it right away, but we can use one of the tricks that we learned previously, writing it in terms of a radical expression. So I can write this as x raised 9 let's not go that far, take that back, because we have not covered that bit yet. So we'll just stop right there. That's good enough for now. So when we simplify, the best we can do is write it as x raised 9/2. So the bases are identical, which is x. So I'm going to put the common base and combine the exponents. Luckily, we have a common denominator, so I can combine the numerators directly. So 9 minus 2/11. 9 minus 2 is 7, so we get 7/11. So the bases are identical, so I can add the powers. But unfortunately, in this case, I don't have a common denominator, so I can't combine things directly. So I need to find the common denominator. The common denominator in this case is 6. So I multiply and divide 5/3 by 2. So 5 times 2 is 10. 3 times 2 is 6. Multiply and divide 7/2 by 3. 7 times 3 is 21. 2 times 3 is 6. Now we have a common denominator. 6. Numerator 21 minus 10. So x is 11/6. A cube. So just like how we could apply a root to individual terms inside the root, the properties of exponents make it clear that if we have a bunch of terms in product inside an exponent, we can apply that exponent to each term. So 4 raised 3 times x raised 5/3 raised 3 times y raised 2/3 raised 3. 4 raised 3 is simply 64. The 3 and the 3 will get cancelled there and there. So we will have x raised 5 multiplied by y squared. So I'm going to take care of the numerator first in this problem. The bases are identical, so I'm going to add the powers. So 1/4 minus 1/2, that's an easy one to do, but I'll demonstrate finding the common denominator regardless. So multiply and divide 1/2 by 2. The common denominator is 4, so we could combine the numerators. So 1 minus 2 divided by 4. One minus 2 is -1/4. Divided by a raised 2/3. I'm going to move the negative exponent from the numerator to the denominator so that I just have positive exponents in the denominator. The bases are identical, so I'm going to add the powers. The common denominator here is 12. So I'm going to multiply and divide 2 over 3 by 4. 4 times 2 is 8. Divided by 4 times 3, 12. Multiply and divide 1 over 4 by 3. 1 times 3 is 3. 4 times 3 is 12. Now we have a common denominator of 12. So we'll have 1 divided by a, raise the common denominator, and combine the numerators. So the answer is 1 divided by a raised 11 over 12. Sure, I can move this term from the denominator to the numerator, but we have a constraint in the question that we express only in terms of positive exponents, so I'm going to leave it as is. So if we can split a radical, we can also split a rational exponent because they are one and the same. So I split the numerator and I'm going to split the denominator also. So numerator would simply become x raised 5 over 3, y raised 2 over 3, divided by x raised negative 1 over 4. Y raised negative 2 over 4 is simply negative half. Just like we dealt with terms separately when it came to regular exponents, we're going to do the same with rational exponents. So first, I'm going to combine the x bases. They are identical, but they are in division. So x raised numerator minus the denominator. Since we have minus 1 over 4 already, it is minus of minus 1 over 4. And y raised 2 over 3 minus of minus 1 over 2. So we will have x raised 5 over 3 plus 1 over 4 times y raised 2 over 3 plus 1 over 2. The exponents that we have do not share a common denominator. So we have to find the common denominator, which is 12 for x. So multiply and divide 5 over 3 by 4. 5 times 4 is 20. 3 times 4 is 12. Multiply and divide 1 over 4 by 3. 1 times 3 is 3. 4 times 3 is 12. For y, the common denominator is 6. Multiply and divide 2 over 3 by 2. 2 times 2 is 4. 3 times 2 is 6. Multiply and divide 1/2 by 3. 1 times 3 is 3. 2 times 3 is 6. Now we have a common denominator. So we can combine the numerators. So for x, it is 20 plus 3 over 12. For y, it is 4 plus 3 over 6. So the final answer is x raised 23 over 12 and y raised 7 over 6. Are we clear? Any questions? Not seeing any. So I'm going to apply the exponents to each term. So I have a raised minus 2 over 8, b raised 3 over 8, a raised negative 3 times negative 1 over 4 is positive 3 over 4, multiplied by b raised negative 1 over 4. Numerator will have negative 1 over 4, b raised 3 over 8, over a raised 3 over 4 times b raised negative 1 over 4. I am going to move the a term from the numerator to the denominator, because it would make the power of a to be positive, and move the b's to the numerator. So b raised negative 1 over 4 would become positive 1 over 4. A raised negative 1 over 4, when it comes to the denominator, it would become a raised positive 1 over 4. Now that we have all the terms, we need to have a common denominator and add. The numerator, we have 3 over 8 and 1 over 4. The common denominator is 8. So I'm going to multiply and divide 1 over 4 by 2. That would give me 2 over 8. The denominator, I already have a common denominator, so I'm going to combine the numerators. So I will have b raised 3 plus 2 over 8 over a raised 3 plus 1 over 4. So b raised 5 over 8 divided by a raised 4 over 4, which is simply a. Going to apply the exponent to each term. So 2 raised 1 over 4, 1 over 2. Y, 2 raised 1 over 4, 1 over 2. X raised negative 5 times negative 1 over 2, 5 over 2. Y raised negative 3 times negative 1 over 2, 3 over 2. We can move all terms from the numerator to the denominator, because we will get positive exponents that way. The denominator exponents are bigger than the numerator exponents, and since we want positive exponents, I'm going to move all of them to the denominator. So x raised 5 over 2 times x raised negative 1 over 2. y raised 3 over 2 times y raised negative 1 over 2. So the bases are identical, so I combine the powers for x. Same, the bases are identical for y, so I combine the powers for y. Five over 2 minus 1 over 2. Common denominator of 2, so I combine 5 and minus 1. Same, common denominator is 2. Combine the numerators, 3 minus 1 over 2. 5 minus 1, 4. 4 divided by 2 is 2. 3 minus 1 is 2. 2 divided by 2 is 1. And y raised 1 is simply y. So the answer is 1 over x squared times y.